Hey everyone, Stefan Burns here. We just had a 5.1 X-class flare blast off from the sun just a few hours ago. Boom! Shakalaka. That is the sixth largest solar flare that we've had in this solar cycle 25. Months ago, I was talking about how this fall we would very likely see a second peak in solar activity. That confirms it. That launched a colossal coronal mass ejection towards Earth that is expected to hit us in less than 24 hours. The initial velocity estimate on this is about 1,850 kilometers per second. You do the math, Earth and the Sun are 150 million kilometers apart, and well, what you get is about 22 hours for that transit time. Now, there are already two solar storms in front of this one that are about to hit us and expected about less than 12 hours. So what's going to happen, and the first one launched was the slowest, the second one was faster, this is the fastest. It's a perfect situation for a pancake where one solar storm catches up to the other, which then catches up to the other one after that. So that is the situation that we have right now, and likely we're going to get a triple sequence where we get the first one to come in, then we get a bigger shock to follow, and then this third shock should really send us into a pretty crazy geomagnetic storm. And as a result of that, we're likely to see G4 conditions. I would not be surprised if we get a G5 geomagnetic storm within the next 2 days. I think we're almost certainly guaranteed G3 conditions. That's a strong geomagnetic storm. I'm putting the probability of G4 conditions at probably like 80%. And a G5 storm, I'd say it's probably about a 50% chance that we get a G5 storm, maybe even like 55, 60%. I think the combination of these solar storms 1, 2, and 3, with this new one being very fast and very strong, this being a very special event that just occurred on the sun, I think we're looking at almost certainly G4 conditions. Probably, I think the majority percentage is G5. It's possible. It certainly can't rule it out. G5 is certainly possible. So we just had some really, really big energy releases on the sun. What's interesting about this is that it's been following nearly a perfect 25-hour frequency. Just want to show you the X-ray flux really quick. It's really pretty wild. We're going to look at where the light radiation from this hit. Here we have our X-ray flux past 3 days. This flare here was at 7:30 a.m. Universal Time. This one here was at 9:10 Universal Time. This one was at 10:04 Universal Time. And this is a 1.7 X-class flare, 1.2, and this is a 5.1, 5.2 solar flare. And so that's about 25 hours in between each, meaning it's been hitting the same location in terms of its light flux on the Earth 8.3 minutes later. Because you get a big explosion on the sun that shoots light photons out. Those are traveling at the speed of light, 300,000 kilometers per second. They reach Earth in 8.3 minutes, instantly charge up the ionosphere, the global electric circuit energizes. Then the actual plasma that was shot off is traveling at different velocities. The first one was, I think, like 800 or 1,000 kilometers per second. Then the second one is like maybe 1,400 kilometers per second. This one clocked in at 1,850. That's the calculation by NASA. So that's 1,800 kilometers per second, not 300,000 kilometers per second, which is why it takes hours, not minutes, or even days to reach Earth. Now, this is pretty wild. Because this immediately triggered a S2 proton radiation storm, and it's a very hard proton radiation storm. Here we see the peak impact of that solar flare. R3 radio blackout over Africa, specifically really South Africa, the southern part of the continent. But you see that this hit all of the Middle East and going up into Europe, so smack dab over this part of the world, hitting both the Indian Ocean and also the Atlantic Ocean. We see tons of particle flux coming into our polar cusp, southern hemisphere, northern hemisphere, because of the ongoing radiation storm that we are already in, S1 levels, and then this has strengthened to S2 levels. And that's actually, here's the big thing. Like, this is really rare, like very uncommon. We are in right now a ground level enhancement. The particle flux is of such a high energy that's actually reaching down to the surface and energizing the ground surface with enhanced ions. So it's called a ground level enhancement. It's very uncommon. You have to have a very big solar flare to cause that. And we are in one right now. And when that happens, you are actually increasing the conductivity of the troposphere as a result. So there's that 5.2 X-class flare, and you can see how it dropped off. So really big, fast, intense bursts of light radiation, extreme ultraviolet light, X-ray light, and almost immediately afterwards, because it was so strong, almost immediately afterwards, these particles started coming in because they're traveling at speeds just less than the speed of light, relativistic speeds. So it may be 200 kilometers per second. It may be 100,000 kilometers per second for some of these particles, which we can check out here. This is our proton flux as measured in geosynchronous orbit. And you see that we're in an S2 storm. You get that level when the red line goes over this zone right there. So you go over the warning threshold, you're in an S1 storm, okay? You don't get them that often, but every now and then with big explosion, you get an S1 storm. S2, pretty rare. S3, S4, even, or like S5, like it starts to really scale off. But S2 is a pretty big proton storm. But here is the key thing right here. This orange line is for proton flux, greater than 500 mega electron volts. This line almost never moves. You see here with this first increase, that was the big solar flare explosion yesterday. Look at how our 500 mega electron volts flux didn't even budge. It's like, yo, I'm not moving. What that is showing you is that the explosion was so powerful, it was able to accelerate protons to an extremely high energy, because their energy is based upon their velocity. So it's not based upon something different, because the protons have the same mass. So it's a mass and it's a velocity equation. So for it to go up here means that some of them, the explosion is so powerful, the magnetic fields and the electric voltage gradients were so steep that the particle passing through it immediately went like this. Accelerated to 500, basically accelerated to almost the speed of light, giving it an energy greater or equal to 500 mega electron volts. And that is what's causing this ground level enhancement. Very rare. You almost never see these. And so this is speaking to how this is really charging up everything on Earth right now. The entire Earth right now is being charged up to a huge degree as a result of this ground level enhancement. It's very rare. Here we can see that with our neutron monitor. And so this is a proxy for cosmic flux, cosmic ray flux. So typically the highest energy particles coming in are from the cosmic environment. They are able to pierce through the heliosphere. They are able to pierce through the magnetic field of the Earth, and then they go ahead and impact. And what happens, they create these particle cascades, and we see the neutron flux increase. That's a byproduct of these particle cascades. Here is where we were, just chilling up until 10:04 a.m. and look at how immediately that flux increased to off the chart. This goes up to 60%. It went off the chart. I don't know if this is 100%, 200%, 5,000%. Some of these GLEs can go into the 1,000% range. So really, really intense spike in the hardest and most powerful particle flux coming into our planet, which we typically only see from the cosmic environment. And we don't get spikes like this from the cosmic environment as like basically in recorded history. We'd have to have some like supernova impact or something like that. I mean, or a Miyake event if it's a cosmic origin Miyake event. So we see that it had this quick spike, and now it's staying elevated at about 15, maybe about 15% higher than normal. Here's our past 30 days. We see that we dipped down because when you have a solar storm impact, usually it actually drops this sort of cosmic flux because it's called a 4-bush decrease. It effectively sweeps out all the cosmic particles that are hanging out in the area coming in, it sweeps them out because the coronal mass ejection has a very powerful magnetic field, so it sweeps them away. So that's why we get this to go down. But with these most powerful solar explosions that trigger these sort of ground level enhancements, you see that actually increases the neutron flux. So the entire Earth going from its magnetic field to the plastosphere to the ionosphere, down even deeper to the troposphere where we live, is right now being enhanced with its conductivity, and that is really quite significant. So this is very abnormal, and effectively the Earth runs off of the geophysical circuit, the global electric circuit. So things like earthquakes, volcanoes, they are all connected to this. So when you get this huge increase in conductivity in the atmosphere, that can help close different circuits that can then maybe make things rupture or explode. Like it's the moment you go below the surface, everything gets conductive and electromagnetic, because you get to about 500, 550 degrees C, and that causes things to effectively melt. They undergo, they lose their magnetization if they had any, but now they are conductive. So if you have remnant magnetization, you may have some conductivity to you, but if you definitely reach certain temperatures, you become malleable, and basically like the subsurface, as you go further down, there's more and more conductivity, more free electrons. So you have these really powerful electric currents that flow through the surface at the ground. But what happens is there's this resistive layer above them, which is the crust. Like the upper crust is very resistive compared to, let's say, the lower crust and the mantle. Really that boundary is about 35 kilometers down. It's a p-n junction. We have a change in the semiconductor type from p to n. So the crust is pretty resistive. The atmosphere is even more resistive, but up above in the ionosphere, it's not that resistive. It's pretty conductive. So when you all of a sudden have everything change and the conductivity increases, you can start to have energy flow up and equalize between the layers. And there's a tremendous amount of potential energy in both the deep Earth and also in the ionosphere and plasma environment, plasmasphere. So if you get flows of energy passing through certain key structures, which like a volcano is already a more conductive channel, right? Magma is melted. It's already a more conductive channel. You could see things happen there if it causes certain changes to finally trigger, you get that domino effect. So the big area to watch is Japan. As I've been mentioning, here we have our earthquakes for the past 7 days in Japan. I've been posting about this on Twitter X if you've been following. Quite concerned about Japan right now. Thankfully, it seems to have died down a little bit. We have one earthquake here today, a 4.6, and then we had a 4.5 before that, a few hours before the 11th universal time. We see 5.2. Here's our 6. So after that 6, the sheer frequency of earthquakes has gone down, but that does not mean that we are out of the woods yet. We really need to see this completely cool off for at least a few days, if not even a few weeks, to be like, okay, that's probably what that was. Because as I can show you right here, what has just occurred in Japan is almost identical to what occurred with the foreshock sequence before the magnitude 9.1 Great Tohoku earthquake. So we're looking at total seismic energy release for the different magnitude ranges. For the past week, this is calculated last night, so it's missing that 4.6 and I think probably that 4.5, which doesn't really matter. And then 1 week prior in red. So we see that our cumulative, like our total seismic energy release for 4 to 4.9 magnitude earthquakes is nearly identical for these two time periods. Our magnitude 5 to 5.9 total seismic energy release measuring gigawatt hours, also almost exactly identical. We've had more total seismic energy release in the 6.0 to 6.9 bracket than for the Great Tohoku earthquake, but there was that foreshock sequence, but there was a 7.3 magnitude earthquake in that foreshock sequence, which released the most seismic energy of all of this. This is a log scale. So the total cumulative difference between what's happened this week and what happened the week prior to the magnitude 9.1, these swarms being roughly in the same location, as you can see, with roughly the same number of earthquakes in the 4 to 4.9 and 5 to 5.9 brackets, right? This is about 4 times more energy. So I did the calculation. If we can assume a linear relationship here between the amount of energy with this foreshock sequence and the amount of energy with the main quake, that was a 9.1. If you do a quarter of the total seismic energy release of a magnitude 9.1, that gives you a magnitude 8.7. So I don't know if that's a relationship that holds, but I think the universe kind of tends to operate in a simple way. At least that gives us a starting point. We don't know that's going to occur. I think it's much higher probability than normal right now. It's a very high risk. If you're in Japan, please be prepared for this. We hope nothing happens. But with now this new solar flare, 3 solar storm impacts coming in back to back to back, and this GLE, this ground level enhancement, the S2 radiation storm, I mean, the Earth is so charged up right now. And then maybe even it's after these impacts that we could see some really big earthquake activity. Regardless of Japan, we're looking at certainly an earthquake watch coming in during and after these solar storm impacts, like high magnitude earthquake watch. So there's no guarantee, but with all the factors and what I know based off of the research I've done and having tracked this stuff for a while, that is definitely something that we need to be prepared for. So these are almost nearly identical except for that magnitude 7.3 that occurred for this one. 1/4 of the seismic energy release, but the overall swarm was very similar with the lower magnitudes. Maybe we're looking at something magnitude 8, magnitude 8.5, 8.7. I don't think we're probably going to go beyond an 8.7. If I had to put an upper cap, that's what I would say, unless we get a magnitude 7 that turns out to be a foreshock. In that case, maybe we do go even higher. But very, very troubling activity here. This could just be super residual activity for the Great Tohoku earthquake 14 years later, which is pretty bizarre. It could be, I don't know. But it's worth tracking very closely. So that is one of the big things happening right now. If we go back to our sun, here we see this 5.1 X-class flare, okay? Now I want to give you a viewer-sensitive warning right now. I'm going to show you something that's pretty flashy light. A lot of flashing lights. I'm only going to show it for a little bit, but I want you to be aware of that. Let's check out the shock wave created by that. Okay, so we have our differential imagery right here, and we can turn off this. Check out that shock wave. That is a big coronal mass ejection. Check out the coronal dimming that occurred, right? This is no joke. So that is headed our way. That shock wave is inbound and going to hit us. We can look at it from a different angle right here with our stereo A coronagraph imagery. So this is from our stereo A probe, which is 30% ahead in Earth's orbit, looking at it from the side. So the Earth is effectively in front here. And we see that now because the sunspot group is starting to rotate towards stereo A, it's also going to impact stereo A. It's a partial halo for stereo A, but look at the plasma density on that. And look at the velocity on that. It's huge. Now, looks like the bulk of it is going to the north, but it's certainly going along that ecliptic plane because it's also going to the south. So Earth is going to get hit directly by this. It is going to be very intense. It's very certainly going to catch up to the others and give us a triple impact. We can look at our space weather model that we have from NASA for the bulk of the coronal mass ejection. So they create 2 models. They create a shock model, they create a bulk model. The shock model is always going to be faster. That's the shock wave. It's the fastest part. The bulk model is slow. This bulk model looks like a shock wave model. That's how fast this coronal mass ejection is. So this is set to sweep by on the 12th, later in the day, according to this NASA first run model. And this is quite significant because the others are expected to come in shortly before this. So we can look at our NOAA space weather model. Maybe they've updated it. I don't think they probably have yet, but hopefully they've updated it already. I think they just updated it. No, this is the 10th. This is our old model, but let's check it out because I can effectively just fill you in on this. So here we go. We'll get this running. And so they show one slow wave, second wave coming in faster, and then there's the third one's not shown yet because it's not modeled, okay? But imagine that first one going and then the second one catching up and the third one being even faster. That is what that model is going to show probably just in a couple hours. There's going to be a 1 then it's going to be a 2, and then a 3 really fast, and all of them sweeping by simultaneously, starting in about 12 hours, maybe less. We could have this coming in less than 12 hours. Certainly, though, in 12 to 24 hours, unless God himself intervenes and does something wild, I don't know, we got this happening. So this is already expected to give us a G3 storm just from these 2 solar storms. But now with this third one, most powerful, 6th strongest flare in solar cycle 25 and the 39th strongest flare ever observed, well, we have some big storming coming up. We have our CCOR1 coronagraph imagery here for the past 7 days. I just want to show you all the activity that's been directed to Earth over the past 7 days. We've already had some geomagnetic storming that reached G3 minus levels from these impacts right here. These sunspots started to rotate closer and closer to Earth. They were flaring basically almost every single day. But the last 3 here, it'll start up on the 9th. The last 3 are really intense. We did get a bit of a cool off from like the 6th to the 8th or so, thankfully. But starting on the 9th, the sun turned angry. It woke up on the wrong side of the bed and it's just like, no, I'm tired of these earthlings. Let's go. So here we'll see our first one. Again, it was at 7:30 a.m. There's that first one. Not the strongest, but that's what is headed inbound. Some of the plasma stayed on the sun. It kind of redirected. Second one here coming up. That's a pretty nice full halo coronal mass ejection. That is inbound faster than the first one. And here's the third one to really top it off. This is a big coronal mass ejection. Check out the velocity on that. Really fast. So that is what we have happening right now with our wonderful sun. And we can go forward in time again to watch the last 2, because these last 2 are the most significant. We have it right there. And then that's already a big one. And then we get this new one to follow up even faster. Happy 11/11 right here. Boom. Boom shakalaka. So yeah, really quite significant. And something interesting I want to show you, because this is just a good comparison to see if you're tracking solar cycles. And of course, all this being said, there's a chance to see aurora now down to low latitudes if you have good weather. So I know a lot of the United States right now is in like a big cold snap because we had some really cold air come down from the North Pole. Maybe that'll give us some clear skies though for some places, certainly not Chicago. But there's a really high likelihood of seeing aurora down even to lower latitude zones. I mean, people in like dark sky conditions in Arizona, you may want to give aurora, do some aurora hunting over the next 2 days or so. So that's certainly possible. If you're in Canada, Alaska, Northern Europe, Siberia, I mean, you're going to be so happy. The magnetic field fluctuations are going to be crazy, but you're going to be so happy. So here we have our number of C, M, and X class flares for the past 3 solar cycles. Solar cycle 23, solar cycle 24, solar cycle 25. And I'm just showing you this because there's different ways of measuring a solar cycle. You can look at the sunspots. You can look at the solar radio flux. You can also look at the number of flares. And this solar cycle has been very notable for its huge number of C-class flares. Also, a lot of M-class flares last year and a good amount of X-class flares. So this solar cycle has been exceptional in many ways. Now, of course, you know, in comparison to the whole record that we have, this has been about an average cycle. But as it relates to the past 20 years of energetic activity from the sun, right? That's most of my life. Well, that means that you're experiencing, a lot of people are experiencing these things for either the first time and or it's been a long time since they've experienced it and now they're older. You know, when you're older, you just have a little bit less resilience. Your biology is just a little bit more tired. There's a little bit more inflammation. So this energy is very, very stimulating. It activates the sympathetic nervous system, gets the whole nervous system charged up. It can be really good for a few things if you know how to utilize it. If you're outside, walking and moving your body, you're exercising, these things are good. It helps you utilize that energy. If you have creative passion projects that you can pour yourself into, you can really have some creative breakthroughs with this energy. But if you're letting this energy just kind of sit in there and just zzz like this, then it can maybe short circuit you. So it's important to be mindful of that. But this is a very strong solar cycle compared to solar cycle 24 and compared to solar cycle 23 if we go by the number of C, M, and X-class flares. In 2025, that bar is only going to continue to go up because the year isn't over yet. So really intense activity during this solar cycle, and this could be something new that you've never felt before or you haven't felt in 20 plus years. So really quite intense. Whew. I would like for this model to be updated, but I think it's going to take a little bit more time than we have in this video. This is the storm that we are in right now, our radiation storm. We have more that we can talk about. Let's also look at 3i Atlas, because this is something that's also in play. We've been talking a lot about this interstellar object. These sunspots are now starting to rotate towards 3i Atlas. So they first started getting really active when in exact alignment with 3i Atlas. Now they've nearly completed a rotation. We're seeing them get active again, like the most active again, as it's rotating closer and closer and closer. So that's kind of interesting. And what's new about 3i Atlas is that it's now forming a pretty significant tail. So we weren't observing really anything coming off of it in terms of a tail before its perihelion. There was like, yeah, kind of maybe a little bit, like it was really unclear. Nothing like a typical cometary tail. Even had like an anti-tail at some points. Then a few days ago, it started spewing out different jets. We have a forward jet right here. There was also one to the north. This latest imagery here from Gianluca was taken by the Virtual Telescope Project. And this is linked in the video description, this webpage. So there's various jets. Now there's a pretty significant tail coming off. So the plasma environment is increasing around 3i Atlas. Like that area of space typically has nothing there, right? And now there's something there with a strong magnetic field and an ionosphere and a whole bunch of ions and gas and dust and plasma forming a big tail. It's interstellar, so it's spewing material from a completely different star system. Our interplanetary space is kind of like a known composition, right? This has a totally different frequency, vibration, and resonance to it, hurtling through our solar system, the fastest ever comet observed. What is this? I don't know. A lot of people now are really hammering the fact that it's a comet, and it does display very similar things to a comet, but I'm just keeping it as interstellar object because we don't really know what it's made out of. We have some spectroscopic data, but it's interstellar, which makes it quite bizarre. So I just think that's a limiting label to put on it. It doesn't appear to be aliens though. Thankfully, it does not appear to be aliens. It's staying on its trajectory. It's doing normal interstellar and space things. So it seems that this alien invasion angle can finally be put to bed. But I'll keep you up to date. I've never been the gung-ho on that, but I've been entertaining all possibilities and looking into them with an open mind. But this is really looking like a interstellar comet more and more, or at least a very unusual interstellar object. So that is 3i Atlas. It's in our inner environment right now. Let's look at the sky live to pull this up, because you'll see that these sunspots are rotating closer and closer to it day by day, which is pretty interesting. Today is the 11th of November, and maybe that's going to mean that solar activity is going to increase further and further as we get closer to it. Here we have our sky live. I've shown you guys this many times. And so this is the Earth right now, right here, and these big sunspots are effectively right about there right now. So in maybe about a week's time, they're going to be lined up at 3i Atlas again. But actually a little bit less than that, because 3i Atlas and Earth are getting closer and closer together. We have our play date with 3i Atlas on the 19th of December. That's our closest that we get to. So as we keep moving in, 3i Atlas is moving closer towards our angle vector from the sun. And as you'll notice here, we actually have a significant alignment that occurs right around the 20th of November. I've been talking about this. This is quite rare. We have a very, very, very significant alignment with the sun, Mercury, the moon. It's a new moon on the 20th, the Earth, and Uranus, all of them in a perfect line. So we have the closest planet to the sun, Mercury, in alignment with Uranus, the second furthest planet out at 20 astronomical units. And also Uranus and Mercury are seen as octaves of each other. So Uranus is often referred to as the higher octave of Mercury. There's a resonance between these two planets. So the fact that these two are in alignment, we also have the new moon signifying a new start, a new cycle, something, increased tidal forces and more. And not only is it a new moon, it's a micro moon, meaning that new moon is going to be as close to Mercury as possible because it's going to be at its apogee. It's furthest away from the Earth, about 420,000 kilometers. So it's almost like it's reaching out to get closer to these guys. Meanwhile, we have this alignment here, and this is in a harmonic aspect with Saturn and Neptune, which are nearly conjunct right now, as you can see from the heliocentric perspective. That's a 1 in 37-year cycle. That's a 37-year cycle, 35, 37 years. And then we also see this harmonic aspect with Pluto there. So they are in this 60 degree, 120 degree aspect. Very critical planetary geometry. We're already seeing really extreme activity from the sun right now, and perhaps we're going to see really extreme activity from the Earth very soon. So that is the update for you today. Wanted to show you what is happening. We have impacts coming in about 12 hours according to the space weather models. Certainly within 12 to 24 hours, we should expect the initial impacts to come in. This coronal mass ejection launched off at about 1,850 kilometers per second. That's very, very fast. And as a result, that is likely to catch up and reach the other coronal mass ejections very quickly. And actually, we have our new space weather model. Okay, here's something interesting. We're not signing off yet, folks. Here we go. Here's our latest space weather model from NASA. And look at this double impact. So 1, 2, boom, boom. That's what it's going to be. That is the energy right now. So I'm not here to bark at you, but that is probably the most accurate representation of the energy right now that I can give you. It's just standing here for 5 minutes barking at you because that's what the sun is doing right now. So yeah, we have some really big energy coming in. And I think at least a G3 impact, 80% chance of G4, and a pretty high chance, like probably 55-60% of a G5 impact. We'll have to wait to see what the official forecasters say, but that is, I think, those are my numbers that you can go off of. I never give you certainties because that is foolish. We're doing forecasting here, so we want to assign probabilities to things and hopefully be as accurate as possible. So yeah, big activity right now from the sun and just in general in our interplanetary space with 3i Atlas, all these other comets and more. So please smash that like button, help the channel grow. I've been your host, Stefan Burns. Thank you all so much for watching. I'm wishing each and every single one of you well. If you appreciated and enjoyed this video, that's what we do. We cover what's happening energetically here on Earth. We look at geologic events, solar activity, space weather, planetary resonances, cosmic things, everything. Then please subscribe. I'll keep you up to date every step of the way. I go live right when things happen as soon as I can. Release videos almost daily. Love to see you here. And if you'd like to pick up some official channel merch or some of the all organic holistic wellness products that I have at earthevolution.com/store, this is tea blends, coffee, and more, then you can click this box right here. If you want to watch a really long interview video podcast I did with Matt Bell on his Limitless channel, I go into a lot of stuff, get the full tea, the download, then watch that video right there. Thank you so much and have a great day.